Hello everyone, my name is Jacob Woodard, and for the final project, I chose to do the Intel Core i7-1165G7 processor. This processor or chip is actually in the computer that I own currently. I'm excited to give a rundown of everything about this processor, its details, its architecture, its speed, memory registers, and so on, and we are going to discuss that further in the presentation. To start the presentation off, we are going to talk about the clock speed and the purpose of the Intel Core i7-1165G7 processor. For the rest of the presentation, to simplify things, I will refer to this processor as the Intel Core processor. So, to start off, the purpose of this processor is to provide high-performance computing. It is designed to provide high performance in laptops to allow for various functions such as multitasking, programming, gaming, and content creation. This chip has 4 cores and a fast clock speed, allowing processes like I just mentioned to occur. The base clock speed of this chip is 2.8 gigahertz per second. This means the chip or processor can execute 2.8 billion cycles per second, otherwise known as instructions. The Intel Core processor also has a boost speed, which is going to be 4.7 gigahertz per second, which means that 4.7 billion instructions can be processed per second. The base speed is going to be the minimum guaranteed clock speed, while the boost speed is going to be the maximum guaranteed clock speed. This is significant because there are certain tasks where it will be beneficial to have a higher clock speed. The clock speed can be dynamically increased for this processor depending on the given tasks or conditions. So this processor has a really good clock speed essentially. And for everyday tasks like browsing the web, word processing, and multimedia, 2.8 gigahertz per second is more than efficient. For gaming, this processor isn't known for gaming, but it does have that boost speed of 4.7 gigahertz per second, and speeds of 3.5 through 4.0 gigahertz per second are sufficient for gaming. So this processor really is fantastic because its boost speed is really high, which allows the user to have sufficient speed for gaming. Now we are going to transition into internal registers for this processor. Well, first let's talk about what internal registers are. Essentially, these are high-speed memory that is built into the CPU chip for quick access to data. For the Intel Core processor, there are going to be 6 categories of registers. These 6 categories include general purpose registers, instruction pointer registers, flags registers, segment registers, control and system registers, and floating point and single instruction multiple data registers. For this processor, we'll start with the general purpose register, which is going to be used for a broad range of tasks. These tasks include arithmetic, logic, data movement, instruction, execution, and addressing. Essentially, general purpose registers are going to have less specific tasks to complete compared to special purpose registers. It's just going to be general tasks that the CPU will perform. The instruction pointer register is significant and important because it's going to keep track of the next instruction to be executed. This will allow the computer to access instructions quickly for execution to enhance program flow. The flags register will store the condition or current state of a processor's operations. The main purpose of the flags register is to store and indicate the result of logical operations. These results are indicated as carry, overflow, or zero. If the result does not fit the register, then the carry flag is going to be set to 1. And considering the overflow flag, if an overflow is caused when an operation results in a value that is too big or too small to fit in the appropriate destination, is when an overflow is caused. The 0 flag is quite simple. If the operation is 0, then the flag is set to 1. Now we are going to talk about the last couple of registers for the Intel Core processor, and we'll start off with segment registers. These are 16-bit registers that are used for dividing memory into segments and for memory addressing. These registers will be used to access physical memory. However, considering this processor, segment registers are mainly used to store threads. A thread essentially performs a task of a larger job. A thread is like a worker working on one specific task. For example, opening Microsoft Edge would be a process, and there are multiple tasks within that process. So a thread would be loading the page. The segment registers are used to store each individual thread. Next, we have control and system registers. These are registers that help the CPU function and behave properly. Control and system registers will control core functions such as turning features on and off, managing performance, managing security, and tracking memory problems. Lastly, we have floating point and SIMD registers. A floating point register stores floating point numbers. The floating point numbers are stored as a binary representation of a real number with fractional parts. The SIMD registers store integers or floating point numbers. However, the SIMD register differs from the floating point register because it allows single instructions to operate on multiple data elements. For example, the CPU can do the same operation on multiple numbers. If you wanted to add 8 to a list of numbers instead of going number by number, SIMD can perform this operation all at once. Overall, these are the registers within the Intel Core processor, and we describe the functions. Now we are going to jump into instruction set and bus size for the Intel Core processor. So, this processor uses a 64-bit instruction set. This means that the processor can handle large amounts of memory. Therefore, it can process more instructions at once, resulting in faster performance. Essentially, the chip can handle data in chunks that are 64 bits wide. This means that the chip can process, move, and store 8 bytes of data at a time, which is really efficient. The 64-bit instruction set ultimately means it can handle bigger numbers in an operation, it can handle larger chunks of data, and access more memory, and ultimately this is going to result in higher performance. Regarding the bus size of this processor, it is 4 gigatransfers per second. This means that 4 billion pieces of data can be transferred per second across the bus. Essentially what this means is that 4 billion chunks of data can be transferred between the processor and other parts of the computer every second. This is a really good bus size, and that is why the Intel Core processor is used in efficient, thin, and light laptops. Next, we are going to dive into the memory and cache of the Intel Core processor. The Intel Core processor chip has two types of memory, which is RAM, or random access memory, and these are going to be the DDR4 3200 and LPDDR4X 4267. The DDR4 3200 is the typical type of RAM that you see in laptops. The 3200 portion of this means that the memory runs at a speed of 3200 million transfers per second. In the LPDDR4X 4267, the LP is going to stand for lower power version of RAM. This version of RAM is good for thin and light laptops. It's going to run even faster than the DDR4 3200, and it's going to be running at 4 million, around 4200 million transfers per second. Lastly, the chip also has a maximum memory capacity of 64 gigabytes. So this is a lot of memory, and this is going to allow the laptop to have high functionality and performance. Next, let's talk about the cache. So this processor unit has 3 different cache levels. We have L1, L2, and L3. The cache is used to speed up access to frequently used data. That's essentially its purpose. So the L1 cache is the fastest and is used to store code, which is instruction cache, and data, which is going to be the data cache, that is currently being worked on. And the L2 cache is slightly slower than the L1 cache and stores data that will potentially be used next. Lastly, we have the L3 cache, which is the slowest and is going to store the most commonly used data that might need to be accessed again. Now that we have talked about the Intel Core processor and its qualities, its benefits, its power, and efficiency, because of these qualities, there are many applications that we can dive into. So I'd like to talk about some potential markets for this chip. Some potential markets that come to my mind are artificial intelligence and smart devices. Because this processor has such high efficiency and power, I think it can be implemented into the AI market. However, there are chips already designed for AI, and this chip won't have the power to run large artificial intelligence applications, but it does have the power to run light artificial intelligence applications, which can be very useful. I don't think it would be a good fit for maybe a computer scientist or a data scientist because they are going to need a lot more power, but it can definitely be used for learning purposes in light artificial intelligence applications. Also, since this processor is powerful and it is efficient, it can definitely be used in smart devices. For example, it can be used in smart touchscreen kiosk at the mall. It would be able to run fast searches and maps to help individuals find their way around the mall to shop. This same logic can be applied for embedded systems. Embedded systems are essentially small computers built inside of devices. For example, a security system that identifies people in real time would be an embedded system. The perks of the Intel processor perform well enough to be adopted into these embedded systems. However, technology is advancing rapidly in our world today, and over the next 5 to 10 years, this chip might be utilized for even low level laptops. I know that what we just talked about for AI markets and smart devices can be true, but for this to happen, we might need enhancements to this chip. And the more improvements and enhancements we make to technology and processors like this one means the less we will need the older chips and processors that have been created. For example, if a chip or we'll take the Intel Core processor, for example. If it is heavily improved on and a new generation comes out that has much better features, it's going to be utilized more in the market than this Intel Core i7-1165G7 chip, as we were talking about in this presentation. So I think it's also important to note that its usage could potentially go down due to the ever-evolving technology market. Lastly, I would like to transition into talking about the cost of the Intel Core processor. This processor, as we have mentioned, has excellent performance and is widely used in the marketplace. Unfortunately, as I was conducting research, the number of sales or chips currently in use is not publicly displayed. However, from the research that I conducted, it suggests that millions of units have been deployed globally since their launch. Also, the 11th Gen Intel Core family has reported revenue of $40 billion since 2021, and this processor is within the 11th Gen Intel Core family. This processor has contributed significantly to this family, suggesting that this chip is widely used because of its high performance and power efficiency. I did do a little bit of research as well for laptops that hold this processor, and there's a wide variety of prices. On the lower end, it was around $450 to $500, and it goes all the way up into the thousands of dollars for even better performance in laptops. Now I would like to wrap everything up. So we have talked about clock speed, we have talked about the Intel Core processor's purpose, its use of internal registers, we've talked about the instruction set, suitable applications, the cost, memory architecture, and more. I think what we can conclude from taking a deep dive into this processor is that this processor is widely used. It does have room for potential future markets like artificial intelligence and smart devices. It has excellent performance and power efficiency and is widely used in colleges right now, in workplaces right now. This is a very, very good processor from what I have learned, and it has been so fun taking a deep dive into this processor for my final project.